Okay, so we've just got the data streamer version of this MCC configuration working, and we're plotting it. You can see the frames that we've sent from the PC side. So this is the data streamer MCC configuration that we have set up, and in this video what we're going to do is get the DV Runtime version set up. There's a lot which actually the DV Runtime simplifies for you if you're looking to visually represent what's happening in your application. So we're going to have a look at that in this video. We will close the Data Visualizer and MCC. See, it's giving you a notice to cancel if you want. And I'm going to Ctrl-Shift-P, MCC launch, and now choose the DV Runtime pseudo configuration. Remember, we haven't really set it up properly yet. Okay, so our MCC configuration opens and we can start to complete the to-dos associated with the example component. So we go fairly quickly with what we've done before. So add component I2C host. Yes, it's there already. We've already selected an I2C peripheral, and we know that this is the one connected to the I2C bus. We're going to just rename this to be I2C host, matching the code that we generate from the example component. Interrupt driven, yes, so that is already there. Select pins for I2C, serial data, serial clock. So remember, we got this from here. Pinouts for all C nanos. Found our board, the Q43, and so serial data RB2, serial clock is RB1. So serial clock is RB1, serial data RB2. Okay. Remove delay, it's no delay, so add component timer, we did that. Select a dependent MPLAB, we've done that. Interrupt driven, yes, by default, so it should be there already, and we have a 100 millisecond timer. So 100 millisecond timer, and interrupt is enabled by default. If error, well, there's no error, so we can check that off. Select a lead pin. Lead pin is RF3. I need to select it first. Pins RF3 as an output. You can see that confirmation there, and done. So we've done the basic config of the example. Now we'll get on to the actual visualization, which is the difference here. Application builder, remove UART. Yep, we've done that. Go to the content manager. So if DV Runtime wasn't there, we'd go to the content manager and find it, and make sure we select a version. Add the DV Runtime, we've done that. Timer, select any MPLAB, we've done that. Timer 1. UART, select serial CDC port UART, we've done that. Select pin for transmit, so pin for TX is RF0. RF0 is TX, RF1 is RX, and we want with RX, we want a weak pull-up enable. RX, weak pull-up, and that's because the data visualizer is going to be sending commands to the board, and so the UART needs to respond quickly. The RX pin needs a pull-up there. In fact, any communication with the UART, generally the RX pin you want to pull up. Okay. So IO debug, that's here. RB4 pins, RB4 output pins, debug. Okay. So that is our config done. Generate code, and we can see, yep, code is generated. We come back into our project, DV Runtime, examples, copy, go to main, replace this, cut, what was our timer? Timer 0 in our application. Note that we're just blocking while the host is busy. Okay, let's just save, Ctrl+Shift+P, clean and build. Now the DV Runtime. Build is successful. Let's go to this config. There we go. DV Runtime is in the middle there. Let's start debugging. Okay, we enter the session there. Now, there are some instructions on setting up the DV Runtime, which is probably useful to be aware of. So, you're going to click to start a DVRT session. You're going to select the source and set up the COM port settings. And the important thing is selecting a debug or production ELF. Now in VS Code it doesn't look like there's a distinction here, so we're just going to make sure that the timestamps for the ELF are what we are selecting is matching what we've done in our project. And then we're going to be able to find any volatile or static variables in our code as symbols in the ELF file and add those directly to the project. It's going to be useful to kind of contrast that to what was the experience with the data streamer, where we have to manually add those variables and update their values before we can send a frame. Okay, we're going to be able to then take the streaming table and pull it to the bottom, and we're going to be able to see a time plot. Okay, what I'm going to do before we start debugging is come into our project config here and go to the properties, and in the DV Runtime I'm going to just go down to the name of the ELF file, and I'm going to say prox sensor dvrt .elf. Save and close this, and find DVRT. Yeah, so there's our output path, so it's going to be under here, output, and we should see our ELF pop up there. Okay, so let us go back to the data visualizer. Now we don't have the data visualizer open. Ctrl+Shift+P, data visualizer. So we're going to start a DVRT session. We're going to select a source, stop this, and we went to the launch. Here, DV Runtime run. Open launch.json, example project, MPLAB debugger. Okay. So the DV Runtime kind of likes to have this, the actual file, callbacks, data streamer, DV Runtime. So here, choose the DV Runtime option, start. Okay, we can start it running. Let's go to the data visualizer. See if we can find a debug symbol, the proximity sensor, the project, and the output. there's our dvrt.elf. So we open that up, and now as we start typing, we have a proximity sensor value. Yeah, it's popped up, and if we check our code, we have a proximity value and a frame count. Frame count. Okay, and if we run this, stop. Oh, we need to add these to the plot. And there we go. So immediately we have something that we can actually control. Like we can change our frame count back to 0. So any variable in your code you can immediately update, so you can control that from this side. We can add our Debug IO as well here. And Debug IO wants to be connected here as well. Okay, anyway, so this is now running. Where's the DVRT? So yeah, we can theoretically change like the streaming tick in terms of how often we send this, but just note in our application it's already set up that the time is only updating the value every 100 milliseconds. But you can check out the DVRT example in the user guide. So where's MCC? So here we go. And if we scroll down to the one with the code here, well, first of all, here's a nice use case, and then there's some code here which here you can change timer periods and things like that at runtime. So what this series has kind of demonstrated is just a lot of all the different kind of process flows as getting things running in VS Code. It's quite a nice flow once you get into it, and yeah, keep playing. Lots of possibilities. Thank you.